My dear friends, how are you doing? Hope you are doing fine. Now we are going to continue with our lesson where we are dealing with integration. Last time, on integration, of the form sine to the power of mx times cosine to the power of nx dx. We stopped where we were going to assume m and n are both even numbers. I do need to know where. I want to know whether you're watching and the voices are well. If you are there, please let me know it. If you're listening, I want you guys let me know by writing in the comment section. Let me know if you are listening to me. I need to zoom the video. Okay, hope this is somehow clear. And let me set it like this. Okay. Hope the video is clear, guys. Hope the video is clear. Okay. Hope it's somehow clear. Those who are watching can let me know. They are telling me that nothing they are getting. Let me share my video to them. I'll let you, sir. How are you doing? Is the video clear? Okay. Is the video clear? Please check your WhatsApp group. I gave you the second link. I've given you the second link. And I want you to tell me if it's clear. Nothing you see? Don't you see me? Please share the link with your friends. Share it with your friends. We are Now about to start. Let me check on my computer to see. Okay. Things are clear, guys. Things are clear. We can start. Yesterday, we said that when both m and n are even numbers, what we do, what we do is we need to linearize sine mx and cosine nx, so that this product will be expressed in sum of sine and cosine, one of them, sine or cosine. So to linearize, we know that from linearization, we know that cosine is equal to cosine x is the exponent of ix plus the exponent of minus ix divided by 2, while sine x, here we change this positive to minus, here is exponent of ix minus exponent of minus ix divided by 2i. Okay, this is what we do. Hope we can have an example. We can have an example. Let's let it here. We are going to linearize. Yes, Sam. Here is the integral of sine power 4 of x cosine squared x dx. Someone is telling me that I'm not live. I need to share him the link. Okay. Let me do it first so that you continue our class. Here is the link of my 11s. Okay, as you see, the sine of the power of sine is 4 and the power of cosine is 2. That's why, because both of them are even numbers, we need to linearize it. From sine x is exponential of ix minus exponential of minus ix divided by 2i. Sine to the power of 4 will be exponential of ix minus exponential of minus ix divided by 2i power to the power of 4. This is equal to exponential of ix minus exponential of minus ix power 4 divided by 2i to the power of 4. Just remember that I power 4 is equal to 1. So I can write this as the product of two squares, where I can have exponential of ix minus exponential of minus ix for 2 times exponential of ix minus exponential of minus ix to the power of 2 divided by 2 power 4, that is 16. I told you that I power 4 is 1. Okay. We are going to use the formula, the square of a minus b, This is the square of a minus 2 times a times b plus the square of b. And I do want to remind you that I power 2 is equal to minus 1. Sine power 4 of x will be, let me have 1 by 16 here, and this for 2, according to this formula, we are going to have exponential of 2ix minus 2 times exponential of ix times exponential of minus ix plus exponential of minus 2ix into, we need to multiply again itself. Here is exponential of 2ix minus 2 exponential of ix times exponential of minus ix plus what? Yes, plus exponential of 2ix, but here is minus. Okay, now this is going to be, you know that a power n, m times a power n, this is a to the power of m plus n. That's why here we are going to sum up ix and minus ix to have the power of 0. Now we have 1 by 16 into exponential of 2ix minus 2 plus exponential minus 2ix multiplied by exponential of 2ix minus 2 plus exponential minus 2ix. This is going to be a reciprocal of 16 into this times this will be exponential. You know, when you multiplying two numbers of the same base with different powers, we sum up their powers. The base are the same and powers are the same. That's why they be summing to 4. Here is 4ix. This times this here is minus 2 exponential 2ix. This times this will be, I guess, summing the powers. This is positive while this is negative. The power will be 0. So we'll be having e equals 0, which is 1. Add 1. Let's use this minus 2. Minus 2 times this, that is minus 2 exponential of 2ix. Minus 2 minus 2, that is 4. Minus 2 times this is minus 2 exponential of minus 2ix. Again, let's use this. This times this will be e equals 0, and e equals 0 is 1. Here is 1, guys. This times this, that is minus 2 exponential of minus 2ix. This times this here will be minus exponential. Summing these two powers, we have minus 4ix. Okay, so we are going to collect terms with powers which have different signs. Okay, you see, here we have e power 4ix, and here is e power minus 4ix. That's why you are going to collect them. But here must be plus. This and this is going to be plus. Okay, here is 1 by 16 into exponential 4ix plus exponential minus 4ix. Let me group like this. Again, this and which one? This and this, they will be summing to 0. One of them is minus, while other is positive. Here is, yeah. Okay, here is 1, but here is minus. You have minus 2, that is minus 4. Exponential of 2ix, and again this and this, as you see, this minus 2 minus 2, that is minus 4. That's why I'm going to factor minus 4, and here b plus exponential minus 2ix plus the remaining are, we have 1 plus 4 plus 1, that is 6. Here is 6. What we do, we need to keep a factor over half so that we'll be able to make, in other words, cosine of theta is exponential of I theta plus exponential of minus I theta divided by 2. While here, sine theta is exponential of I theta minus exponential of minus I theta divided by 2i. So we are about hitting the final answer. This is 1 by 16. Sorry, let's factorize 16 by 2. I have 1 over 8 times 1 over 2 plus exponential minus 4ix minus 4 into exponential 2ix plus exponential minus 2ix plus 6. We need to take this half and divide it here everywhere inside the braces. Okay? But before doing that, because here we have a product of sine power 4 and cosine power 2, what we are going to do is to look for the linearization form of cosine power 2 so that the multiplication for us will be easy. Okay. Let's now linearize cosine. We know cosine x is exponential of ix plus exponential of minus ix by 2. That's why cosine for 2 will be exponential of ix plus exponential of minus ix divided by 2 or to the power of 2. We have exponential of ix plus exponential of minus ix for 2 divided, what is the share of 2? That is 4. This is going to be, let's have 1 over 4 into exponential of 2ix plus 2 exponential of ix times exponential of minus ix plus exponential of minus 2ix. The linearization form of cosine squared x is going to be a quarter of, as you see, this product is 0 is 1 because exponential of ix times exponential minus ix, that will be exponential of 0, which is 1. So we have exponential of 2ix plus exponential of minus 2ix and then plus 2. In other words, sine power 4 of x times cosine squared of x is going to be, guys, it's going to be, we are going to have this and multiplied by this. As you see, let's start by multiplying the numbers. 1 over 4 times 1 over 8, that is 1 by 32 times half into exponential 2ix plus exponential minus 2ix plus 2 times this. Here is exponential 4ix plus exponential minus 4ix minus 4 into exponential 2ix plus exponential minus 2ix plus 6. Okay, we are going now to expand the multiplication. Let me hope that is clear everywhere. Okay, here we're gonna have a reciprocal of 32 times a half. We need to take this and multiply it inside here. That is, this times this will be exponential of 6ix plus this times this will be exponential of minus 2ix. This times this here will be minus 4 into this will be multiplying here. It will be exponential of 4ix. When this multiplies here, the powers will sum to 0. That's why we'll be adding 1. Okay. This times this will be 6 times exponential of minus 2ix. Okay. Is this minus? Not. We are using this. So next, we are going to use this. Plus, this times this will be exponential of 2ix. This times this will be plus exponential of minus 6ix. This times this here is minus 4 into this times this. The exponents will sum to 0. That's why we are going to have 1. This times this will be exponential of minus 4ix. So the next is to use this to this. This is going to be plus 6 exponential of minus 2ix. Okay. The next thing you are going to do is to use this. Let's add 2 times this. That is 2 times exponential of 4ix plus 2 times this exponential minus 4ix minus 4 into this. Is that minus 4? This times this will be minus 8. Okay, minus 8 into exponential of 2ix plus exponential minus 2ix. Then this and this will be plus 12. This is going to be 1 over 32 times a half stuffs whose power is 6. Let's look at them. Stuffs whose power are of different signs but looking the same. This and this, guys, have powers of different signs. That's why here I'm going to write exponential of 6ix plus exponential of minus 6ix. Let me group this. Let's jump to those whose power are positive 4 and minus 4. Okay. This has positive 4 and this has positive 4, but their coefficients are different. So we need to have minus 4 plus 2, that is minus 2. Let's write here minus 2 into exponential of 4ix. Let's go to that whose power is minus 4i. We're going to have this times this, that is minus 4 exponential of minus 4ix, and add this, that will be plus, that will be minus 2. and minus 2 must be factored to be plus exponential of minus 4ix. So the next, we jump to those stuffs with exponential of 2ix. Okay. Look, this and this will be 7. Okay, 7. Is it on 7? Yes, 7 minus 8. 7 minus 8, that's gonna be e exponential of 2x. But what about those whose power is negative? Negative 2ix. This minus this 6. The next is 6 minus 8. That is minus 2. Where did we make a mistake? Is there any mistake? We've taken this and this. Okay. Yes. And next, I've taken this and this. The next one, this and this. Where is 6? Yeah, this and this, 6. That's it. This in here. Okay. It's looking fine. Now, let's now continue using this. Gonna have till here we have 6 and this. Okay, this, right? Okay, 12. Have we made a mistake? I don't think so. Okay. We have exponential of 2ix. Exponential of 2ix must be there. Okay. Let me expand the multiplication instead of writing it myself to avoid those mistakes. This is 1 by 32 times a half into, okay, let me even have this quant. We now have 1 by 32 times a half of, here is exponential of 2ix plus exponential minus 2ix plus 2 times, here is exponential of 4ix plus exponential of minus 4ix. Here will be minus 4 times exponential of 2ix minus 4 times exponential minus 2ix. Then here is plus 6. Here is plus 6. Now, this is 1 by 32 times a half, as I told you. This one times this will be exponential of 6ix. This one times this, here is plus exponential of minus 2ix. Okay, This one here, this multiplies here. This is going to be minus 4 exponential for Rx. This one multiplies here, that is minus 4. This one multiplies here, this is plus 6 exponential of 2Rx. Now we are going to do this. Let's write it here. Okay, it doesn't matter. This times this is going to be exponential to Rx. This times this is going to be plus exponential minus 6 Rx. This times this here is going to be minus 4. Yes, minus 4. This times this here is going to be minus 4. Then this is exponential minus 4 Rx. This one times this is going to be plus 6 exponential minus 2 Rx. Now we are going to use so let's now plus 2 times this is 2 exponential 4 Rx plus 2 times exponential minus 4 Rx here. This times this is going to be minus 8 into exponential 4 Rx. This times this here is going to be minus 8 times exponential minus 2 Rx, then plus 4. Okay. What is this? Here is 1 over 2 times 1 over 2. Here is the exponential of 6 Rx. Those with 4. This has the power 4I and this and this have the power 4. That's why this is going to be minus 2 times exponential 4 Ix. We have done on this and on this with this. Okay. The next are those which are the power of 2 Ix. This one, that is 7 exponential to Ix minus 8, that is minus 1. Here is minus exponential to Ix. I've done with this, and with this. Okay. Let's now go to those whose powers are minus 2Ix. This one minus 2Ix. This one plus this one, that will be 7 exponential to Ix. So, and this is going to be minus exponential minus 2Ix. The next are those whose powers negative 4. The powers are negative 4. We have this one minus 4 exponential 4Ix plus 2 times exponential minus 4Ix. That is minus 2 exponential minus 4Ix. And we remain with what? With exponential minus 6, that is unique. And we have only one term, which is this. Where is minus exponential minus 6Ix. We're going to see the sum of independent terms of E. We have minus 4, that is minus 8. Minus 8 plus 12, that is 4. And now we have used 4. Okay. What we are going to do now is to group those terms whose powers are the same with different signs. Now, well, 1 by 32 times a half into, well, exponential of 6ix plus exponential of minus 6ix. Let's do this. Those whose power is 4 in minus 4. We have minus 2 into exponential of ix e to the power of 4ix plus e to the power of minus 4ix. Those whose power is 2 and 2ix and minus 1ix. Both of them are minus, that's why I need to factor by minus of exponential of 2ix plus exponential minus 2ix plus 4, which is the independent e. Okay. What is going to be done now is to take this out and divide it everywhere. Okay. This is 1 by 32 into exponential of 6ix plus exponential minus 6ix divided by 2. Let's group this. Minus 2 into exponential 4ix plus exponential minus 4ix divided by 2, then minus exponential 2ix plus exponential minus 2ix divided by 2, and here plus 4 by 2, that is 2. Okay. How easy it is. We know the linearization form of cosine theta when because this is exponential I theta plus exponential minus I theta divided by 2. Okay, as you see, here theta is replaced by 6. Okay, theta is replaced by 6. That's why I have 1 by 32 times, here we give cosine of 6x, theta is replaced by 6x here. Okay, now minus 2 times cosine, here theta is replaced by 4. That's why 4x, that's why here is 4x minus, here theta is replaced by 2x, and here is going to be x plus 2. So the next thing, I'm going to divide each term by 1 by 32. Here is 1 over 32 times cosine of 6x minus 2 by 32, that is 1 by 16 times cosine of 4x minus 1 by 32 times cosine of 2x, then plus, what is this? 2 by 32, that is 1 by 16. Okay. Remember our integration equation was integrate sine to the power of x times the cosine squared of x dx. This must be the integral of each term. Here is going to be 1 over 32 times the integral of cosine 6x dx minus 1 by 16 times the integral of cosine of 4x dx minus 1 by 32 times the integral of cosine 2x dx plus 1 by 16 times the integral of dx. Don't forget to make here dx. Okay. I also want to create that remember when having the integral of cosine ax plus b dx, this is going to be 1/8 sine of ax plus b plus c. Therefore, the integral here of sine or 4 of x times the sphere of cosine x dx. This is going to be, we need to multiply this 6 here, okay? We need to multiply 6 here. 6 times 2, that is 12. Here is 1 by 19. 19 to sine 6x minus this 4 must multiply here. Here will be having 16 times 4, that is 1 by 64 times the sine of 4x. These two must multiply here. This is going to be minus 1 by 64 times the sine of 2x plus 1 by 16 plus the constant of integration. Can you have another example, right? Can we? I can give you one exercise. It doesn't matter. It doesn't matter. We need to step to another property where we deal with integration of another form. Here, sine increased by terms and cosine increased by sec. Let me hope you'll be enjoying the course. Okay? Let's hope you'll be enjoying the course. Yeah. We are going to continue to this part. If you have any question, guys, I want you to share it or write it in the comment section. I assure that this time we'll be dealing with the program. Yes, we'll be dealing with the program first in my class. That's why I cannot leave you with some issues. Here is about integration of the form. Here is integral tan to the power of m x times the to the power of n x dx. Okay. We are going to deal with integration of that form. And before I continue, I need to check if you have any problem. In my comment section has no message. This shows me that you really understood the lesson. Now we can continue, isn't it? We can continue. There is no need of DRM. Okay. Let's continue with integration of this form. We need to consider two different cases. We need to consider two different cases, guys. Of which one is if the power of if n is even number, i.e. the power of secant is an even number. An even number. What do we do? What do we do if the power of secant is an even number? We save one factor of sec squared. Save is save one factor of secant squared. Means this is to say the sine, the secant for n of x need to be written as sec for n minus 2 of x times the square of sec x. Here we'll be saving this factor of sec squared and use the identity, then use the identity sec square, which is equal to 1 plus secant squared of x. The next thing that is important is the assumption. You assume, hence, assume u to be an x. You know, the derivative of that is the extract x dx. Okay? Nothing but this. Are you getting this? Well, today's lesson is somehow important. Today's lesson is somehow important. If you are following, I want to know that was a Kevin lot. We can see you. Let me think for her. Crane. His code was a crane. Thank you, crane. If you have any other question, you can put it in comment section. If there is any step that will left you without understanding, let it in the comment section. Okay. The second case. If n m sorry, if m is odd, say the power of tangent, the power of tangent the power of tangent is the power of tangent is odd number. What do we need to do? We need to save one factor of, please save one factor of tan x sec x. Okay, then use the identity tan squared x is sec squared x minus 1. That's it. Hence, assume u to be sec x, where du is going to be tan x sec x dx. We'll be replacing tan x sec x dx by du. Now it's our time to have examples. It's our time, guys, to have examples. Example 1. Examples: integrate tan power 5 x times 7th power of sec x dx. What you need to check is the power of tangent even or odd. We have, if the power of tangent is odd number, we save a factor of sec x and tan x. Okay, means this can be written as, we are going to save one factor of tangent and one factor of secant. Okay, here is tan to the power of 4x times tan x multiply sec, saving a factor of sec. Here we say with sec to the 6th power of x times sec x dx. Okay, this is gonna be, here is the integral. We have tan to the 4th power times sec to the 6th power times tan x sec x dx. Remember, when having this, when saving this factor of tan and sec x as it is shown here, we use the identity tan squared to be sec squared x minus 1. That's why, because this is the integral tan squared x power 2 times sec to the 6th power of x times tan x sec x dx, this will be the integral replace tan power 2 by sec squared minus 1. Here is sec squared x minus 1 power 2, okay, times sec to the 6th power times tan x sec x dx. Guys, this method is somehow clear and can make the question simple. Okay, let's now continue with the question. As you saw, when the power of tan is an odd number, then we save this identity and we assume sec. We assume u to be sec. Now let u be sec x As you saw, du is gonna be tan x sec x dx. We are going to replace each sec by u and tan x sec x by du. This means all of this stuff will be du. Now we are on the integral where you have u square minus 1 per 2 times u to the 6th power times du, because du was replacing this tan x sec x dx. This is gonna be, what we need to do is to expand u square minus 1 all to the power of 2, that is u to the power of 4 minus 2 times u to 2 plus 1, then times u to the 6th power. This is going to be the integral u power 6 times u power 4, that is u power 10, minus 2 times u power 6 times u power 2, that is u power 8, u power 6 times 1, that is u power 6. Here is the u. There must be the u. We have seen that the integral of x power n dx is x to the n plus 1 divided by n plus 1, then plus a constant of integration. Now, our integral is going to be, here we have the power of 10. Adding on here, we'll be having 11. That's why here we have u power 11 divided by 11. Here is minus 2. 8 plus 1, that is u power 9 by 9, plus 6 times 1, that is 6 plus 1, sorry, that is 7. Here we have u power 7 by 7. And then we add the constant of integration. Hence, the integral of tan power 5 times sec power 7 x dx. This will be, because our u was assumed to be sec x, we are going to replace u by sec x. Here is 1 over 11 times sec to the power of 11 x minus 2 over 9 sec, here the power is 9, sec to the power of 9 times x plus 1 over 7 sec to the power of 7 x plus c. This is the answer to the given question, guys. Let's try the second one. The second one will be about, it's about, oh, let me look for it. Yeah, the next question that will be looking like a knot, sec to the power 4 tan to the power 4 dx. What is this? How do you see this stuff? The case you have is when the power of m, the power of tangent, is an odd number. But here, our power is even number. Remember, this can be expressed in terms of sec. Okay? It can be expressed in terms of sec. We do this way when the power of sec, the power of tan is odd. When it becomes to even, we use this stuff. Okay. Here is, let me call it example 2. This is the integral, tan square, tan power 4 can be the square of tan squared x dx. Okay? And this is going to be the integral. Tan square can be expressed as sec squared minus 1 per 2 dx. This is where we use integration by here is x, by here is x. We assume, when having this, we assume u to be tan. Okay, assume u to be tan. Okay. Uh, yes, this can even be tan squared x sec squared x dx. Assume u to be, here is tan squared. I'm sorry, here is tan squared. This is the integral of tan squared x into sec squared x sec squared x minus 1 dx. Okay. Assume u to be, let u be tan x. Du is gonna be, what is the derivative of tan? It's sec squared dx. And you remember, here we need to find the value of dx. Okay, the value of dx. Dx is gonna be du divided by sec squared of x. Remember, sec squared is 1 plus tan squared. So dx here will be, it's gonna be du by sec 1 plus tan squared x, and tan was assumed to be u. Here dx is gonna be du by 1 plus u power 2. Okay, we need to continue here. Here we had tan power 4. That is, we have u power 4 divided by our dx is du by 1 plus u power 2. Here is 1 plus u square du. As you have seen, when the power of numerator is bigger than that of denominator, what we do is a long division. We do a long division. That's why, because here we have the power 4, we need to take u power 4 and divide it by u square plus 1. Taking u power 2, here u power 2 times u power 2, that is u power 4. When it comes here, it changes to minus. Here is minus u power 4. Here u power 2 times 1, that is u power 2. And when it comes here, it becomes negative. This vanishes this to stay with u power minus u power 2. Because here is minus, and this is positive, we need to take minus 1 here. So that minus 1 times u power 2 will be minus u power 2. When it comes here, it will change to positive. Here positive u power 2 minus 1 times 1, that is minus 1. When it comes here, it will be changing to positive 1. This and this will vanish to 0 to stay with 1. So u power 4 is equal to u power 2 minus 1, we add this remainder divided by 1 plus u square. Okay. Okay. Now, instead of writing this, we are going to have the integral of u power 2 minus 1 plus 1 by 1 plus u square du. We are going to integrate element-wise. Here, the integral of u power 2 will be u power 3 divided by 3 minus the integral of 1, that is u, with respect to 2, that is u, plus then the integral 1 over u square plus 1, all 1 over 1 plus u square. You remember this formula where the integral, let me have it here, the integral of 1 by a square plus x square dx. This is equal to 1 over a times inverse tangent of x over a plus c. In our case, x stands for u, while 1 stands for a. Now, this will be u power 3 over 3 minus u plus a will be replaced by 1. We'll be replacing 1. Will be replacing a. That's why we are going to have 1 by 1, that is 1 times arctangent of x of 1, that is x, plus the constant of integration. Okay. I'm going to leave you some examples, guys, about this unity, because 2 questions are somehow enough. We'll be stepping forward to integration containing sine x, cosine x, tan x on denominator. Okay, and I will leave you a little time to write this exercise. Those are the questions for practice. If you need to learn, please, to be genius, you need to try. Nothing is impossible. Everything is possible, but through your will of working. Everything is possible through your will. Uwimana Michael, teacher nta kintu kiri kugaragara. Thank you. I'm coming to correct the mistake, if any. But things are clear. Uwimana, text me on WhatsApp. I need to give you a link to join. Someone is asking, can you teach us the last units of senior 4? Yes, I will try. It doesn't matter. The time will be yours. And I'm really available. Okay. Any other question? If you have it, please leave it in comment section. If you have any question, I want you to leave it in comment section. Uwimana Michael, do you have any question about mathematics? Any question about our lesson? Do you? If you do, precise any unit, the unit you want us to discuss about, because I work for you, not for my own. Okay. Our next unit is about the integration containing sine, cosine, and tangent on denominator. Okay. Integration containing sine x, cosine x, and tan x, but on denominator. That is where we are going to step forward. Do you see nothing? Nothing you see? Please let me know your position. Let me know your position. Do you see nothing? Which unity do you want us to cover, dear friends? Which unity do you want us to cover? I'm there for you. Uh, can you help me to share the lesson, please? Can you help me to share the lesson? If you didn't join my community, I do want you to join it today. To be one of my followers, my subscribers. Please go there and subscribe to the channel. It costs nothing. Go there and subscribe to the channel. It costs nothing. Okay. Now let's continue to this stuff. We are going to deal with integrations like a plus sine x dx, a plus cosine x dx, all integration ux divided by a plus sine b sine x, let's write here b sine x plus c cosine x plus d tan x. Tan x, here is dx. Don't worry, you do not have to worry. Okay, you do not have to worry. What we do here, we use t substitution. What to do? We express both sine and cosine as the tangent of half angles. Let me show you how. You know sine x is equal to the sine of x over 2 plus x over 2. Guess what? Hope this you are familiar with this. This is gonna be, we have 2 sine x over 2 cosine x over 2. You getting this? Now, dividing sine x by 1, we need to express this sine x in terms of tan of x over 2. This is gonna be 2 sine x over 2 cosine x over 2 divided by, 1 is the sum of sine squared of any angle and cosine squared of the same angle. Because here we have x over 2, this is going to be cosine squared of x over 2 minus plus sine squared of x over 2. You getting this? Now, to continue, this can be seen or expressed as a tangent function if we divide every by cosine x squared. Divide on denominator by cosine of x squared. Let me have it like this. We have 2 sine of x over 2 cosine of x over 2 divided by cosine squared of x over 2. Dividing here cosine this stuff, we are going to have cosine squared of x over 2 by cosine squared of x over 2. That is 1, it's 1 plus. Here is sine squared x over 2 by cosine squared x over 2. This is going to be, I need to simplify these 2 and this cosine. The remaining will be 2 times sine x over 2 by cosine x over 2. Sine over cosine, that is a trigonometric ratio, which is tangent. Here is 2 tangent x over 2 divided by 1 plus. What is this? Sine squared by cosine squared, that is tangent squared of x over 2. This is looking like a proof. Okay, if you didn't know where this comes from, I have shown you the proof. It comes from there. Now let's continue with the lesson, guys. Are you sure, Queen? Are there no voices? Teacher Komarki Yabai Ichiwazo. I'm so sorry. I forgot to on the camera, the mic. But now I hope that the voices are there. Voices are there. Let me open another mic, guys. Let me open it. Okay, it's on. It's on. It can't work while being charged. Thank you very much, my dear friends. But hope you see everything here. Let's hope you see it. If you do not understand, I can go back to the question. If you didn't understand the question, I can go back with it. Please, if it's like that, I know where the program is. Please tell me using your WhatsApp. I'm seeing Thierry here typing. Teacher Komargiwa Ichiwazo, this is Ivan Kamo. It's Ivan Kamo. Okay. Can we continue with the question, guys? Yeah. I'm going to give you 1 second example. The second example, example 2, I want you to find the integral 1 by sine x plus cosine x plus 2 dx. Before continuing, I do want to know whether it's clear. I do want to know whether it's now clear. Okay, that is the next question I have for you. Now, to continue with the question, as you saw, sine x can be expressed, here is sine x can be expressed as a function of tangent like 2 times tangent x over 2 by 1 plus tangent squared of x over 2. Now, what about cosine? Cosine x, because here we have sine and cosine. Cosine x was 1 minus tangent squared of x over 2 divided by 1 plus tangent squared of x over 2. What is going to be done now is to replace sine by this, cosine by this. This is going to be the integral here on denominator half of numerator. On numerator half 1, sine is going to be replaced by 2 tangent x over 2 divided by 1 plus tangent squared x over 2 plus, here is plus 1 minus tangent squared x over 2 by 1 plus tangent squared x over 2, then plus 2. Here must be dx. This is going to be the integral 1 by, the common denominator, guys, will be this stuff, because the same as here, it will be multiplying here. This is 2 tan x over 2 plus 1 minus tan squared x over 2 plus 2 into 1 plus tan squared x over 2 dx here divided by 1 plus tangent squared x over 2. Okay. Now we need to multiply the reciprocal. We need to take this and multiply it to 1. This is gonna be 1 plus tangent squared x over 2 divided by 2 tangent x over 2 plus 1 minus tangent squared x over 2 tangent squared x over 2. This 2 is going to multiply this plus 2 plus 2 tangent squared x over 2 dx, and this will be 1 plus tan squared, that is sec squared. Here is sec squared x over 2 divided by, we need to take 2 tan squared x over 2 minus tan squared of x over 2, that is tan squared x over 2 minus this plus 2 tangent x over 2, and here we have 1 plus 3, that is 1 plus 3, 1 plus 2, that is plus 3. Hope it's this. Using use of, we need to assume, as previous, we need to assume u to be tan x over 2 and 2 du we replace sec squared x over 2 dx. Now the integral is going to be all of this will be replaced by 2 du, that is 2 du divided by u per 2 plus 2u plus 3. I need to take out these 2 out of the integral sign. This is 2 by 1 over u square plus 2u plus 3 du. Okay. Can we find u value when equating u square plus 2u plus 3 to 0? Can we get the value of u? Have a look. The discriminant or delta will be 2 per 2, that is 4, minus 12. 4 minus 12, that is minus 8. Can we find the square root of minus 8? This is irreducible quadratic equation. That's why to deal with this integral, we need to complete the squares of this. You see? We divide the coefficient of u by 2. Having 2 by 2, that is 1. So we need to have the square of 1 and add it here and subtract it. So the integral will be 2 times the integral of 1. Here we have u per 2 plus 2u plus 1 plus 2, because 3 is the sum of 1 and 2. Let me group like this. As you see, here is the u. I'm sorry. This is 2 times the integral of, here is 1 divided by the square of u plus 1, then plus 2 du. Hope you remember this. 1 over x squared plus a squared dx. This is a reciprocal of a times arctangent of x over a plus c. In this case, this is going to be These two will be expressed as the square of the square root of 2. Okay, this can be the square root of 2 per 2. Here is the square root, guys. Now, this is going to be 2 times 1 by the square root of 2 according to this formula where a is the square root of 2 times arctangent. This will be replacing x here. That's why here is u plus 1 by the square root of 2 plus c. Okay, so the given integral 1 by sine x plus cosine x plus 2 dx is gonna be 2 by the square root of 2 times arctangent of our u is tan x over 2. Here is tan x over 2 plus 1 divided by the square root of 2 plus a constant of integration. Hope this way is also easy. That is also easy. By now, I can have some exercise for you in order to end up this lesson. Numugabo Kedi amajwi kabisa nayo. Okay, yagarutse. Good, that's good. Uwamahirwe Nelly, thank you very much. Amashusho, is there any problem with video? I guess not, because on my PC they are clear. Okay, dear friends of my YouTube channel, I am also looking for your help of sharing the video. I'm going to have you or give you some exercise about this unit. Maybe my microphone is disturbing, that's why I'm going to off it a little time. Uwamahirwe wakongera ukavuga example 2. Which one? Do you mean this example? Uwamahirwe, please tell me. Do you mean that example 2? Did you face any challenge? Did you face it? Uwamahirwe, any challenge? Uwamahirwe, I want you write anything here. Example 2. Where are you facing challenge? Uwamahirwe. Okay, let me explain it to you. As you see, when dealing with integration that contains sine, cosine, tangent, x, what we first do is to transform sine in terms of tangent of x over 2. Cosine must be expressed in tangent of x over 2. Even tangent need to be expressed in terms of tangent x over 2. Let me have it here. Tangent x needs to be expressed as 2 tangent x over 2 divided by 1 minus tangent squared x over 2. Hope you are getting that. Am I right? If you have understood this stuff, where we change this, after changing it in terms of tangent x over 2, what next is to assume u. Let that tangent of x over 2 be u, and then the derivative sec squared of x over 2 dx will be replaced by 2 du. I think that's enough. If you have any other question, I do want you to announce it to me. I'm going to give you some exercise. If you get nothing, you will be asking. I'll be there to answer your questions. Here are 6 questions for practice. Questions for practice. I do want you to find these integrals. The first one is the reciprocal of 2 plus cosine x dx. B is about the integral 1 by 3 minus 2 times sine x dx. C is about the integral 1 by 2 plus 2 sine 2x dx. D is the integral of 1 by 5 minus 3 cosine x dx. E is about the integral 1 by 3 cosine x minus 4 sine x plus here is plus 4 sine x plus 6, and here is dx. The last question, which is f, is the integral 1 by 3 cosine x minus 4 sine x then plus 5 dx. Do you see any question which looks challenging? If any, let me know it in the comment section. I'll be helping you to understand it well. Level up your likes. Bavandimwe mwese muri live, bibaye byiza mwankandira kuri like. Ikindi mbasaba, nongere musabe nkubwire ko subscribe yawe irakenewe, ni ingenzi cyane kuko iramfasha. Ikindi ni byiza nanone kandi byiza cyane ko ubonye iyi video iri interesting wasangiza bagenzi bawe. Mwese ndabizi mufite inshuti kandi ni inshuti nziza, ufite abandi bana biga senior 6. Ese muri iki kiruhuko ntabwo mwamfasha tukarebana nabo? Muri iki kiruhuko nimwamfasha nabo mukajya mubaha video link bakajoininga live yacu, kuko rwose pe byaza kuba ari byiza. Ese hari ikirungurira bibatera? Kandi ndabizi mwebwe ko muri abantu beza nta shyari mugira, sibyo? Muri beza. Iva Kamel itica ko amajwi yabaye ikibazo. Ntekereze ko yagarutse muvandimwe, sibyo? ntekereze ko yagarutse. Okay. Hari umuntu umwe, ni umugabo Kedi, aranditse ngo twabikora kabisa. I'm appreciating, ni umugabo. Ni ukuri iyi comment yawe ikwiye like. Bagenzi bawe bakumpere like kuri iyi comment. Nta kibazo rwose pe. Ubu ngubu tumaze kugera muri 429. Yego, ni umubare mwiza, buri wese ndamushimira uruhare rwe, ni ukuri mwakoze neza. Nizere ko nta wundi mwanzi waduteranya. Ese uratekereza ko haraho nigeze mwemukira? Niba hahari, muvandimwe, apologize for me. Sibyo? Twese icyo tugamije ni uko twakumva isomo, iyi mibare twayoroshya, kandi niba mubona rwose ibi ngibi byari byiza, bagenzi banyu nabo muzababwire, tujye tujoininga class every day. Ikindi ngiye kubasaba, ntabwo nyifuza ko hari umuntu uzajya ucikanwa n'isomo kandi dufite uburyo twarikoraho, sibyo? Ntabwo nifuza ko hari umuntu uzajya ucikanwa n'isomo dufite icyo twakora. Igihe anytime you got home, you need to text me, ukambwira ngo teacher, can you explain me the lesson that I missed? Ukambwira se teacher, wansobanurira isomo nanisinze? Yeah, I'll be there for you. There is no matter. Okay. Reka turebe on live. You are on number of 13. You are 13. Okay. 12. Another guy goes out. Can we end up our course here? Can we end it here? Or we can continue? No, but I won't continue. I will be telling you the lesson, because at this time I'm going to introduce to you the next course, which will lead us in our next class. So tomorrow we'll be starting from integration containing sine squared x and cosine squared x on denominator. And some proofs will be shown to you in our next class. You made a good job, and I really appreciate your time. Because you have shared this video, we have gained other 4 subscribers. Please keep praying your Lord on this channel. You are really good friends. Most of you have their WhatsApp accounts. I need you to share this video link on your post. Nta kintu byagutwara, kandi ni ukuri pe, ni byiza, ariko tekereza nawe. Ndashimira mwese, nkongera kugaruka kuri Loic, maybe you are not online, but I thank you for much. My thumbs are up for you. Are you listening to me, Loic? I do know the reason why I'm thinking. Okay, guys, let's end up our live here. We'll be continuing tomorrow at 20 or 8:00 p.m. Bye bye. May God bless you, my dear friends. Let's end up the live.